Chapter 1.6, dealing with absolute values. Things that we need to recognize when we talk about absolute value. We talk about the distance of numbers, the distance from zero. So numbers have direction and distances. The directions are considered the plus or the minus, and then the number itself would be the distance. So absolute value doesn't care about which direction the number goes in, doesn't care if it goes left or right, negative or positive. It just cares about how far it is from zero. So all distances have to be positive numbers. You can't be negative 6 feet. You can't drive negative 50 miles. Distances are always positive. So we have this statement. It says the absolute value of p minus 3 equals 10. So one of the things that I teach, how I teach it, is you have this distance, this unknown box in here, right? And we know it says, really what it says is what distance, what number has a distance of 10? Or what unknown has a distance of 10? Well, we know that 10 has a distance of 10 and negative 10 has a distance of 10. So whatever is in this box, whatever this question mark, needs to be equal to one of these two numbers. All right, so when we see this, so we're going to set up two equations, two statements. P minus 3 can equal either 10 or p minus 3 can equal negative 10. That's what this little idea box right here stipulates. That's kind of what is going on, why we have it in this manner. Let's group that and make it a little bit smaller. We'll put that idea up there. So you will see that I will write two statements. I don't want it blue. I kind of thought it was. And now we're going to solve it. Notice that when I write these two statements, the absolute value bar goes away. And now we're going to solve for P. And we want to know what two situations can P have. So the two situations is P can either be 13 or it can be negative 7. If we plug 13 in there, we get 13 minus 3, which is 10, and then we take the absolute value of 10, which is 10. If we plug in negative 7 in for P, we get negative 7 minus 3 is negative 10, and then we take the absolute value of negative 10, which is 10. So those two solutions worked. And when we write our solutions, we write them with braces. These are called braces. And we write them in numerical order. Very important that we write our solution set. That's not numerical. That's not how you spell numerical. Numerical order. And numerical order is small to big. Okay, very important. We all have the same solution set. So we have the absolute value of negative 2k equals 6. So I'm going to write negative 2k can either equal 6 or negative 2k can equal negative 6. We'll divide both sides by negative 2. K can equal negative 3. Or we divide by negative 2 and we get k equals positive 3. And we can check. Negative 2 times negative 3 is positive 6. Absolute value of positive 6 is 6. And if we plug in negative 3, or positive 3, we would get negative 2 times positive 3 is negative 6. The absolute value of negative 6 is 6, and that would be another good solution. So students can write this, and then in high school, a student might write this, plus or minus 3. That is a plus or minus sign. It represents both solutions. Nice, eloquent, beautiful way of writing a solution. My absolute value is isolated already, so I can write my statement 6f equals negative 2. Oh, look at that. I am stopping. I'm in such a rush to write my two statements, I'm not even looking at this statement and noticing something that should be very glaring. No absolute value is ever going to produce a negative solution, a negative value. So it says the absolute value of 6f equals -2. It doesn't matter what I plug in for f, positive, negative, 0, reciprocal, blah, 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 1/3, -1/3. It's never going to produce a negative value. It's always going to, a positive value is always going to come out of that absolute value. So there's nothing. So this answer is actually no solution. That is what you have to notice. So be careful about being so fast to get to the two statements that you don't recognize the most obvious thing right in front of you. Here, my absolute value is isolated. I'm going to write q over 5 equals 3, or q over 5 equals -3. We'll multiply both sides by 5. Q equals 15 is one of my solutions. We're going to multiply both sides by 5, and we get q equals -15. So we can write -15, +15, or we could write plus or minus 15. Now, notice this time there's things not only happening inside the absolute value, but outside of the absolute value. We must simplify, we must isolate, the absolute value. Always isolate the absolute value first. So I got to get rid of that 9. I'm going to subtract 9 from both sides. That gives me the absolute value of -a plus 2 equals -3. Uh-oh, I have an absolute value that equals a negative value. That's no good. So that is no solution. That was kind of tricky, kind of not fun, but it's okay. So, hey, somebody asked me, Mr. Matt, can I distribute that 3 into the absolute value? No, absolute value only wants distance. It doesn't care about direction. And when we distribute a +3 in there, we're distributing a direction. So that's not good. You cannot distribute into an absolute value. You cannot distribute into an absolute value. Okay? So what we will do is we will divide both sides by 3. That's how we'll get isolate. That's how we will isolate my absolute value. And now it's by itself. I'm going to write two statements. 4 minus 3m equals 10, or 4 minus 3m equals -10. Well, minus 4, -3m equals 6. We'll divide by -3. M equals -2. Well, minus 4, -3m equals -14. Divide by -3. M equals 14/3. So my two solutions are -2 and 14/3. No need to change it from an improper to a mixed number. Improper fractions are acceptable answers. So if I plug in, if we look at that starting statement, let's take that starting statement, 3. Let's talk about checking. 3 times the absolute value of 4 minus, what was it? 3m equals 30. If we plug in a -2, Does the left side simplify? So 4 minus 3 times negative 2, we're going to do the multiplication first. And now we're going to simplify still. Orders of operations. Absolute value are a form of grouping symbols. That's why I'm simplifying inside the absolute value. Now I have the absolute value. I have to take the absolute value. I'm not multiplying at this point. I'm doing the absolute value operation. What is the absolute value of 10? Is 10. And that is multiplication between there, so 30 equals 30. So that worked. So I know that negative 2 worked. Okay? And then I can check my other solution, which is 14/3 times 14/3 equals 30. So 3 times the absolute value. Negative 3 times 14/3. The 3's are going to cancel. I'm left with negative 14. And then I'm going to simplify inside there. 4 minus 14 is negative 10. I'm not going to multiply those two. I have to do the absolute value. The absolute value of negative 10 is 10. They drop off, and now I show the multiplication, and I get 30 equals 30. And that worked. So I know both my solutions were correct. We still want to, hey, oh, there's an absolute value equal to negative. Nope, it's not isolated. We have to isolate the absolute value first before we look to see if it's equal to a negative value. And that gives me positive 3, so that is not, it's okay. I can continue on. That gives me 5g minus 12 equals 3, or 5g minus 12 equals negative 3. We'll add 12. 5g equals 15. Divide by 5. Divide by 5. G equals 3. We will add 12. 5g equals 9. Divided by 5. Divided by 5. G equals 9/5. Did I put those in order? Those last ones? Hopefully I put them in numerical order. Yeah. Let's make sure I put these in numerical order. So we have 3 and 5 9/5. 9/5 is smaller than 3. And there's my answer. We're going to minus 9, minus 9. I'll graph the solutions. Nobody's going to make a graph. You're not going to graph just points. It's kind of silly. That's unrealistic. You will not have that in high school math. Not for absolute value equations. Inequalities? Absolutely. Greater than or less than with absolute value, you will absolutely have to graph the solutions, but not equations. Rarely do you graph inequality equations. We have this statement. We have x minus 3 equals 21, or x minus 3 equals negative 21. We'll add 3, x equals 24, add 3, x equals negative 18. Oh, almost made a mistake there, negative 18. So my solutions are negative 18 and 24. If we did have to graph it, we would do this. Negative 18, 0, 24, and you put a dot over both of those. In high school, they may make you do the dots on the line. I hate that. That's a horrible technique. I like doing it above so we can see your solutions. If it's down, you get kids that do this. Did you even notice which one I dotted? And then they expect me to know that? Whatever. And people make them do all these little tick lines. That's just noise. It's just getting in the way. It's not necessary. So, Mr. Mac, give me the solutions. Show me where the answer is. Personally, that's the best, I think. All right, so we have this absolute value right here, and 2 things are happening to it. 2 is being added to it, and 3 is being multiplied to it. I'm going to get rid of the things being added and subtracted first. we have 3 times the quantity times the absolute value, excuse me, of 2d minus 6 equals 0. Let's divide by 3. Divide by 3. We have the absolute value of 2d minus 6 equals 0. Hey, there's no two statements. They're the same statement. It's positive and negative, so we don't have to. This is a unique problem where we can drop off the absolute value because they have the same distance away. Plus 6. 2d equals 6, divide by 2, divide by 2, d equals 3. And in this absolute value, only have one solution. We can mentally throw it in there. 2 times 3 is 6. 6 minus 6 is 0. Absolute value of 0 is 0. Times 3 is 0. Plus 2 is 2. Minus 4, minus 4. 7 times the absolute value of 2c minus 6 equals 28. Divide by 7. Absolute value of 2c minus 6 equals 4. I've isolated my absolute value. Now I can set them equal to the two equivalent distances away. 2c minus 6 equals negative 4. Let's add 6. 2c equals 10. Divide by 2. C equals 5, add 6, 2c equals 2, divide by 2, c equals 1. Let's put it in numerical order. I don't know if I put that in a solution set. I probably would have accepted it, but that's how you put one number in a solution set. Funny how my brain walked me back there. A company manufactures penny number 2 nails that are 1 inch in length. Oh yes. The actual length is allowed to vary by up to 1/3 of an inch. Write and solve an absolute value equation to find the minimum and maximum acceptable nail length. So let's think about this. If we have a nail, kind of looks like this, and they are 1 inch in length, and it can vary up to 1/32 of an inch. So it can be longer, well, let's do it in green. It can be longer by 1/32, or it can be shorter by 1/32. So if this is my 0, right? If this is my 0 value, this is exactly what it should be at. I can be somewhere in between here. I can be between this, and it would be okay. So write and solve an absolute value equation to find the minimum and maximum acceptable nail length. So if we have this absolute value, so it's whatever that value is. Let's do n for nail length, minus 1. So let's think about that. If we have this nail length, if it's 1 in 1/32, 1 in 1/32 minus 1, it'll produce 1/32, and that would be okay, right? That would be the extreme. The other value, the short value, would be, hey, that would be 31/32. And what would that be? Minus 1 would give us negative 1/32, and then we do the absolute value, and that would be okay. We're all right with that? So this is an okay. There are some students that might say 1 minus n. I don't know if I'm okay. It's interesting. I haven't really thought about why one is better than the other, but we'll see in a second. Now, we say that it has to be in between that. So this distance has to be less than, right? Write an absolute value equation to find the minimum and maximum acceptable length. So that has to be, well, technically it has to be less than 1/32, or equal to, sorry, right? So that distance has to be this error. This is the error So let's say if it was 2, right? Let's say if it was a 2-inch nail, that would give me a value of 1. Is 1 less than 1 1/3? No. But let's say if it was a 1/2 inch nail, that would also not work. So, ooh, that's good. So 1/2 inch, yeah, that would be greater than 1/32. So if we put 1, oh yes, let's say it's right on it. You would get 0 is 0 less than 1/32. So yeah, so this actually is an inequality. I don't know how you can write an equation, because you can have stuff in between these two shaded areas. You got some leeway, right? You can have stuff in between here, and you can have stuff in between here. So that's your error. So it doesn't just have to be 1/32. Hence why I wrote an inequality sign. But that's kind of technical, really, really technical. If you had done 1 minus n, I think that still works. I like n minus 1. That's the nail length minus the 1 gives me the error. So that's cool, but it has to be less than. That error has to be less than 1/2. That's why that. A penny number 2 nail is 1.05 inches long. Is the nail acceptable? Okay, so we have to now convert. So we're really asking, hey, is 1 1/32 is our maximum value? What is that as a decimal? So I can do 1 divided by 32, and I get 0.3. 1.03125, I think was the numbers. So if I'm given a nail that is 1.05, is that within it? No. No, it's too long. 1.05 is too long. It needs to be less than, that's the longest it can be. Longest nail. That's the longest nail length acceptable. Okay, so that's too long. It's a good question. I like it. Oh, baby. So we didn't go over this. I taught you absolute value part 1. This is kind of part 2. This is way more advanced. You rarely will see this on an Algebra 1 placement test. You might, but it's not oftentimes included. This is more of an Algebra 2, but when you have absolute values where both sides are absolute value, you are going to, and Mr. Mack has to remember a little bit. He has to, I probably should have dusted off my brain a little bit before I started this video, but we're fine. We can take a peek and make sure that we're doing it correctly. Let's take a gander. Yeah. All we do is, positive, negative. Okay, so we still write 2 statements. This is kind of complex. 9w minus 4 can either equal the positive value of this, or it can equal the negative value of this. And what we have to do is I got to make this a little smaller, move it over a little bit, bring you over, and bring you over. And the negative value of that right side. So notice that negative is outside of parenthesis. So we can just move the variables. Always move the variables first. We'll add 4, 7w equals 14, divide by 7, w equals 2. And now here we have to distribute because we want the opposite distance. So 9w minus 4 equals negative 2w minus 10. We're going to add 2w, add 2w. That's 11w minus 4 equals negative 10. Add 4, add 4. 11w equals negative 6. Divide by 11, w equals negative 6/11. Those are my 2 solutions. I'm going to go back and make sure I did that correctly. Boom. And that's good, and that's good. So that's a horrible negative. I like that better. And we can check it if we want. It's not a bad thing. We'll take this original problem. Let's do this. Let's take a second since it's our first one, and we can check. You should want to check. You should want to make sure that you're doing it correctly and that your solutions work. 2w plus 10. So my first solution was 2. So if we plug in 2, does 2 work? And we're always going to simplify before taking the absolute value. And we get 14 equals 14. So that worked. So we know that 2 was a good answer. That worked. And now we're going to try negative 6/11. Negative 6/11. I think that was the starting problem. 6/11, so 9 times 6, negative 6/11 minus 4, and 2 times negative 6/11 plus 10. So that's going to give me negative 54/11, and we're going to minus, that's going to be 44/11. I just found a common denominator real quick. And negative 54 minus 44 is negative 98/11. Absolute value of negative 98/11 is 98/11. And 2 times negative 6 is negative 12/11 plus 10. Yeah, I converted. So that's 110/11. And that's going to give me 98/11. And absolute value of 98/11 is 98/11. And that worked. So I know that this is also an acceptable answer. That took a minute for each check, so that's not crazy amount of time. We should be able to do that relatively fast. And here we again. So we have 2 times n plus 7 equals 4n plus 8, or 2 times the quantity n plus 7 equals the opposite of 4n plus 8. 2n plus 14 equals 4n plus 8 minus 2n minus 2n. 14 equals 2n plus 8 minus 8. 6 equals 2n. Divide by 2, divide by 2. 3 equals n. Let's do 2n plus 7 equals 14. Did I do that? Yeah, almost made a mistake there. Minus 4n minus 8. Let's add the 4n. 6n plus 14 equals negative 8. Minus 14. 6n equals negative 22. Yep. Divide by 6, divide by 6, n equals negative 11/3. Notice I simplified. Did I write it in a solution set? I don't think I wrote it in a solution set. Negative 6/11. You notice when I'm remembering, I'm like midway through this problem, I'm still thinking about 12. How weird is that? And there are my solutions, negative 11/3 and 3. And I'm going to assume that I'm pretty good. But if you want to make sure that you get 100 on your quiz or test, you would check at this point. Yeah, same thing. So we have 3 times the quantity, 3t plus 1 equals 2 times the quantity, 6t plus 3. Or, oh, it gets so big. My handwriting is so large sometimes. I don't have enough space. And then we have 3 times the quantity, 3t plus 1 equals negative 2 times the quantity, 6t plus 3. So that's 9t plus 3 equals 12t plus 6 minus 9t minus 9t. 3 equals 3t plus 6 minus 6. Negative 3 equals 3t, divide by 3, divide by 3, negative 1 equals t. That's one of the answers. 9t plus 3 equals negative 12t minus 6. Add 12t. That's 21t plus 3 equals negative 6 minus 3 minus 3. 21t equals negative 9. Divide by 21. Divide by 21. T equals negative 3/7. So now let's put them in numerical order. Negative 1 and negative 3/7. Smaller, bigger. I think I'm pretty good. Let's see, negative 1 and negative 3t. Let's look at the answer key. Let's take a look at the answer key. Oh, look, they did good. I like seeing this. So it did x minus 1 equals, okay, yeah, I don't know. I like my inequality. That's a way more advanced. Negative 1 and negative 3/7, yes. All right, so that's good. We feel confident. We feel confident. All right, let's continue on here. Let's do, it's isolated, and we're going to do 5r plus 3 equals 2r, or 5r plus 3 equals the negative distance, or the direction. I'm going to minus 5r, minus 5r. 3 equals negative 3r divided by negative 3. Negative 1 equals r. Minus 5r minus 5r. 3 equals negative 7r divided by negative 7. Negative 3/7 equals r is my other solution. Did I just do that problem? Are those the identical answers? Negative 1. What? Ooh, so I maybe made a mistake. That's 14 and 13. Let me see. Am I 14 and 13? Oh, no, yeah. Ooh, so why is this no solution? 15 they say is no solution. 15, no solution. Why would that be no solution? Am I supposed to check? Or maybe, see, maybe not checking is showing me that oh, I see. You see why? Anybody see why? Excuse me. Because when we plug these values in to this, what's it gonna produce? It's gonna produce negative 2. This value is going to be negative 2, or this value is going to be negative 6/7. And this will never produce a negative. Ooh, how would I guess you wouldn't see that. You don't see it in the work here. Whoa. So only when you check do you see that. So that doesn't work and that doesn't work. So my answer is no solution. Wow. So now you see the value of checking your answers. All right. These are called exclusions. Yeah, you'll learn about that a little bit later too. So those two solutions are called exclusions. Some values, some solutions can come out mathematically, and see, math doesn't know. Math doesn't know about absolute values. It doesn't know that it only means distance, not direction. So you're going to find these situations throughout math where, you know, you're using these algorithms to isolate for the variable, and the algorithms really don't understand the difference between absolute values and squaring and radicals, square roots. So this is an example of, and it doesn't know that negative or 0 can't be in the denominator. That's another place where you see exclusions. So interesting problem. That's good. Glad we did these extras. J minus 5 equals J plus 9, or j minus 5 equals the opposite of j plus 9. That's how we would write that. Oh, minus j, negative 5 equals 9. No solution. That's a false statement. My variables canceled. So that part of the graph has no solution. Doesn't mean that you're done. Just this left part doesn't have any solutions. Then we have j minus 5 equals negative j minus 9. We can add j to both sides. 2j minus 5 equals negative 9. Add 5, add 5. 2j equals negative 4. Divide by 2, j equals negative 2. So this only has one solution, which is negative 2. This would produce no solution on that side of the distance, and this is going to be okay. Wow, that's an interesting one. Now let's test it. Negative 2, let's check it. That equals negative 7. Absolute value of negative 7 is 7. And then negative 2 plus 9 is 7. Absolute value of 7 is 7. So that works. That's the only solution. That was a tricky one. Oh, I see what you're going to do here. Okay, so your first statement is 2k plus 4 equals 2k plus 3, or 2k plus 4 equals the opposite of 2k plus 3, minus 2k, minus 2k. 4 does not equal 3. That's false. So that's no solution again. Here gives us 2k plus 4 equals negative 2k minus 3. We're going to add 2k, add 2k. 4k plus 4 equals negative 3 minus 4 minus 4. 4k equals negative 7. Divide by 4. K equals negative 7/4. That's my only solution again. Let's just check and make sure 16 and 17 had only one solution. 16 and 17 only has one solution, yeah. Good. Okay. Let's move on to 18. Oh, write an absolute value equation as the given solutions. Yeah, this is kind of interesting. So those are my two values. So if we look on a number line, those are my two solutions, and solutions are going to be symmetrical. So remember, there's going to be an equal distance between those two. So what is equal distant between 3 and 9? Hello, 6. And it is, 6 is minus 3 and plus 3. So if I say some number minus 6 should equal 3. And if we plug in 3, you get negative 3. If you plug in 9, you get 3. And that is how you can get the answer. Kind of cool, right? Interesting way of writing it. So you think about just what absolute value means. So that is the only value that works. So, right? I like it. If you plug in, let's say we plugged in negative 3. Well, that would be negative 9, and that doesn't equal 3. So you see, no other numbers work except for 3 and 9. So that's a neat way. We're going to, again, use the number line. Negative 5, 0, 5, 10, 15. So if these are my two solutions, what is equal distant? Equal distant would be 5, and it would be minus 10 and plus 10. So that's my distance. So I would say x minus 5 equals 10. So if we plug in negative 5, we get negative 10. Absolute value of negative 10 is 10. And if we do 15 minus 5 is 10. And that's my answer again. Nice, easy, quick way of writing absolute values for those solutions. Let's do the number. Let's make sure it continues to work. 0, 4, 11. Ooh. So, right, what's going to be in between? What's that distance? 5, 6, 7, 8, 9, 10, 11. There's 1, 2, 3, 4, 5, 6, 7. So half of 7 is 3.5. 1, 2, 3. So it has to be here. 5, 6, 7.5 is going to be my distance. And what is my distance? That's minus 3.5. This is plus 3.5 to get my two solutions. So I would write my absolute value is x minus 7, oh, not 7, x minus 7.5 equals 3.5. That distance can be either positive 3.5 distance away or minus 3.5 distance away. And then we want the distance of that number, not the direction. So this is how you would do that one. That's a fun, tricky one. You conduct a random survey of your small town about having a town-wide garage sale. Of those surveyed, 56 are in favor, 44 are opposed. The actual percentage could be 5 more or 5 less than the acquired results. Right? And solve an absolute value equation to find the least and greatest percentages of your town population that could be opposed. So opposed is going to be 44%. And we have a plus or minus 5. So if we draw this in a number line, you have 44, and then minus 5 would take me to 39, plus 5 would take me to, 49. So that gap is minus 5 and plus 5. And we can think about how we just wrote that equation. X minus 44 needs to be plus or minus 5. So if write and solve an absolute value equation to find the least and greatest percents. So we know that they can be, if we plug in 49%, that's within 5%. What if I plugged in 50? If I plugged in 50, I get 6, and 6 is not equal to 5. So, and technically, again, it needs to be less than or equal to. I don't like that they keep saying equations when they really mean absolute or inequalities. So I'm sure in 21 they're going to show you an equation, but technically it should be a less than sign. A friend claims that half the town is actually opposed to a town-wide garage sale. Does this statement conflict with the survey data? Yeah, because 5% more would give you 49, and that would not be 50%. Yes. Max opposed is 49%. The least opposed would be 39%. So, yeah. So, yeah, yes, conflicts. Yes, it conflicts because the max opposed is going to be 49%, not 50%. Okay, there you go. Those are the solutions for those and the solutions for those, which we went over. And yes, I knew they were going to write an equal sign. That's technically, yes, 50% is not within the range of 39 and 49. Let's go!